Hello everyone, my name is Arman and we are going to do Math 120, Discrete Mathematics 1 this semester in a flex format, meaning that the format is in a way that I'll record the videos and lecture videos and then I will upload them on Moodle. Discrete mathematics is one branch of mathematics, important branch of mathematics, which mostly deals about counting problems, if I want to describe it in a simple way. And so in this course, and it's related, of course, to, it's a branch of mathematics itself, and it's very much related to computer science as well. So for this reason, most students in computer science need to have a basic knowledge of discrete mathematics, or even advanced level knowledge of discrete mathematics if they want to pursue a higher advanced level degree in computer science. So in this course, the topics that we will cover, are the topics that not just discrete mathematics, but also topics related to discrete mathematics, which are very much useful and essential in mathematics and also in computer science, such as basic logic. So that's where how we will start this course, by going through basic logic. Many people in my experience think that mathematics is mostly about numbers, dealing with numbers, and properties of numbers and things like that. So of course, yes, numbers are important in mathematics, but more important than numbers is logic. Basic logic, the statements, the conditional statements. If something happens, then a conclusion, for example. So for example, if it's a Monday, then I go to the mall, for example. So this is a conditional statement. Or for example, if x is equal to 2, then 2x is equal to 4. So these are, but we'll go over them. These are examples of conditional statements. But generally, logic, if, for example, P implies Q, can we say that Q also implies P? So understanding, the concept of statements and basic logic is the essential foundation of mathematics, more important than numbers. Okay, so we will go over, and also in computer science as well, in computer science also, you have to know the basic logic. Even in also for the philosophy, in philosophy, you also need to know basic logic. So basic logic, not just in these fields, even in daily life. Like I said, many examples we can consider in basic logic deals with daily life. So we'll go over basic logic in this course. And the other topics that we will cover will be set theory. Well, set theory is sets, basically, and the properties of sets is also a very essential foundation, a fundamental element of mathematics. What are sets? What are the operations on sets? What are their properties? Again, this field is very important in mathematics and also in computer science. So these are, like I said, fundamental elements of both mathematics and computer science. So these are the foundations. I'm sure you are familiar with sets and properties of sets, but we'll go into more details. And the other element or topic that we will cover is methods of proof. So you are I think, familiar with proofs a little from previous courses. Even in Math 100 pre-calculus, you have some statements to prove or some exercises for proofs that you have to prove simple things. But here in this course, we want to go over formally, we want to go over different methods of proof. For example, direct proof, proof by contradiction, and other methods. So, for example, in pre-calculus, you saw that you can prove that root 2 is an irrational number using proof by contradiction. So in this course, we will go over all methods of proof and with examples, of course. So again, this is a very fundamental element of all mathematics, not just discrete mathematics. In any branch of mathematics, you need to prove statements. So you have to be familiar with methods of proof. Also in computer science, especially theoretical computer science, you need to prove things. So this is also very important. Then we will go over some basic number theory. So number theory itself is a different branch of mathematics. Normally is not considered as a sub-branch of discrete mathematics, but in this course, it somehow can be considered because it involves numbers on integer numbers, which can be also considered as discrete set. But normally it's not considered a sub-branch of discrete mathematics. But in this course, we will go over some basic introduction of number theory. So for example, properties of integers, division algorithm, prime numbers, or a fundamental theorem of arithmetic. So that you have some idea about number theory. But of course, if you want to go into more depth, you need to take a number theory course, which we currently don't have it in the college, but you can take it in, for example, UBC or SFU, basic number theory. I think normally it's considered a third year level course. And we'll also do fundamentals of countings, which is what really discrete mathematics is about. So like I said in the beginning, discrete mathematics is mostly about counting problems. For example, combinations, permutations. For example, let's say this class, I think currently around 15 students have registered. So let's say if I want to choose 2 of them for some reason, let's say, I don't know, let's say some gift, for example, or something. Let's say I want to choose 2%, or let's say, for example, choosing as TA, for example, any type of reason. Let's say I want to choose 2 students out of 15 students that we currently have. So in how many ways can I do this? So let's say if I call this student number 1, 2, 3, all the way to 15. So for example, I can say that I want to choose student number 1 and 2, or 1 and 3, or 2 and 10. So there's so many ways, right? So exactly how many options do I have to choose 2 students, let's say out of 15 students? Or in another scenario, maybe the order is also important for me. So one scenario is that, let's say I want to choose 2 students, let's say to choose as TA. Then both students have same role, so the order is not really important. But what about, let's say, if I want to choose one student as, let's say, main TA and the other student, the assistant to the main TA? So then the order is also important. So in that case, in how many ways can I choose 2 students? Okay, so these are just some simple examples. And this topic is also very much related and important for if you want to take probability theory course, Math 206. So this topic is very helpful there and essential when you, especially discrete probability. In probability theory also can be categorized into two branches, discrete probability and continuous probability theory. So in the discrete probability, you need to know about counting problems and how to perform or solve counting problems. So that's another topic that we'll cover in this course. And also we'll cover relations and functions. So you are familiar with functions from high school or at least from pre-calculus. You know that function is a rule that assigns exactly one output to each input, right? But functions can be considered as a special case of a mathematical object called relations. So cover relations, definition and properties of relations, and then functions and the definition and properties of functions. Of course, some of them you have seen before in high school or pre-calculus. But we'll also, in this topic, we'll cover equivalence relations and partial orderings. So ordering, so right now, I'm sure you're familiar with the ordering of ordering that we have for real numbers or for integers. For example, we can say 1 is less than 2 or 2 is less than 3. So this is an ordering that is defined on integers or real numbers. But what about if you want to define an order on some other type or of some other mathematical objects other than numbers? For numbers, it's obvious how to define ordering. But let's say if I want to compare, in other words, if I want to compare two other mathematical objects, for example, two functions or two vectors, how can I define an ordering for those type of objects? So we'll get the idea from the ordering that we define, an obvious order or trivial ordering that we have for numbers. We will use that to define or provide a formal definition of ordering, which can be applied for other types of objects, mathematical objects. So these are basically the topics that we'll cover in this course. So I told you very briefly about it. And of course, then if you want to know about other important topics in discrete mathematics, then you can also, after this course, you can take Math 221, Discrete Mathematics II. And in that course, you will learn about other important topics such as graph theory. Graph theory itself is also a very important branch of mathematics and also computer science, very much related to computer science. Because, for example, let's say when you deal with data, let's say, for example, Facebook users, and whether there is a friendship between the Facebook users or no. So that can be considered as a graph, and the users can be vertices of the graph, and then the friendship between those could be considered as edge between those vertices. So these are the terms that is used in graph theory. Is not a topic of this course, but if you're interested, you can take, after this course, you can take Math 221, Discrete Mathematics II. Okay, so let's also go over, I've uploaded the course outline on Moodle. So hopefully I've I looked at it so far, but let's go over it quickly again. So let me share my screen. Okay, so these are some basic information about the course. The course number and office hours. Office hours is Wednesday, Saturday, 2:30 to 4:30. So that's, I think, a good opportunity, you know, if you have any questions about lectures or about, let's say, background or prerequisite or questions related to assignments. So any questions you have, you can attend the office hours. That's a good opportunity to meet virtually during those time. And so about the textbook, so the name of the textbook is Discrete Mathematics and its Applications by Rosen. You can purchase this book from Amazon or Vital Source. But please make sure that you purchase the right edition. So the edition that you should use is 8th edition. So the main source for exams and preparation for exams is our lecture notes. But for the assignments, I'm going to use. For the lectures also, I will follow this book more or less. But especially for the assignments, we need the book because I'm going to refer to the page numbers and question numbers from this book for assignments. And I told you about the course learning outcomes and content briefly. So let's skip this part. And then for the evaluation methods. So it's very simple. We are going to have 3 tests and 1 final exam. So 4 tests in total. And for the first 3 tests, so I'm suggesting some time. I try to, because this is a flex time and people have different schedule. So my suggestion is that we can hold these exams for, let's say, sometime during night or evenings that people are have more free time or more available. So let's say my suggestion is, let's say for test 1, as you can see here, 8 to 10 p.m. June 3rd, test 2, 8 to 10 p.m. June 24, and test 3, 8 to 10 p.m. July 15. All in Vancouver time and Pacific Standard Time. So if you can't make any of these dates, so please send me email. So these are all just tentative dates. So I haven't fixed it or finalized it yet because I want to know if there are people who cannot make it. So please, if you can make it, but let's say by changing or moving things around, please do so that we can use and finalize these dates. Because of course people have different preferences, but any time that we choose, there are some people who may not prefer those times. But if there is any way that you can make these dates and times work, please do so. But if there is something that is absolutely you cannot do anything about it, and these times and dates do not work for you, any of these 3 dates and times, please let me know by email by end of this week. And yeah, then we'll go from there. Okay. So by this Friday, this coming Friday, please send me email and let me know if any of these dates, cannot work for you. Okay. So, but these are the dates for now. And so about course policy. So each test, by the way, each test is worth 20%, each midterm. So 60%, and final exam is 40%. The date of the final exam will be announced later. And then about course policies. So I told you about the format. This is Flex, and I record and upload the videos. And yeah, so here I also wrote that, if the dates do not work, please let me know by Thursday. So end of Thursday, 11:59 p.m. would be fine. By Thursday, May 13. You should let me know if any of these dates do not work for you. And so for the exam, so how do we run the tests or exams? So basically, first of all the exams are closed book. And so the way that it works, I always, read the questions out loud for you. And then you're also allowed to look at the screen. I will also share the questions on my screen. I will not send the questions by email or by Moodle. I'll just show them on my screen. So you're allowed to look at the screen, and I will also read the questions out loud for you. And then you have to copy the questions on a piece of paper. And after you are done copying the questions, then the exam will start. And during that time, you are not allowed to look at the computer screen or your cell phone or any other electronic device, or you are not allowed to talk or look around in your room, etc. So we will have usually, around 20 minutes. It takes around 20 minutes to copy the questions. And then let's say around 1.5 hours, you have time to write the solutions. And during that time, you're only allowed to look at your own paper. And then at the end, around 10 minutes to scan your exam and upload it on Moodle again. So I will explain further details when we get closer to those dates. I mean, all the explanations are here, but maybe I'll also send another email, because another important thing is how you should set up your webcam. So basically, you should set up it in a way that, your face, your hands, and your surrounding are all visible. So let's say if you are sitting, let's say, in front of a desk, the surface of the desk should be visible. Or let's say if you're sitting on a bed, the surface of the bed should be visible. And also, of course, your papers should be visible as well. So your face, hands, papers, and surrounding. And like I said, if there is you're sitting on a bed, the surface of the bed, on a desk, the surface of a desk should be visible. So I will send a sample picture about how you should set up your webcam. But all the details are written here. So please make sure, I briefly told you about the exam format, but please make sure you read this part very carefully. About how you should write the exam. And then so about the exams that, we will need Zoom. They are going to be with Zoom meetings. So I will send the link on Moodle, and also for office hours, I will send it by Moodle. And homework. So there will be homework, weekly homework. But you don't have to hand in those homework. So I will just upload the questions again on Moodle. Like I said, using the page numbers from the book 8th edition that we mentioned. So please make sure that you complete all those assignments. You don't have to hand in them, but in the exam, in the exams, 3 midterms and the final exam, I will use those questions. So I will use those questions themselves or a similar version. So most questions, the exams are either similar to homework questions or similar to lecture notes. Of course, there could be some questions that are not similar to any of these two sources, but most questions, at least most questions, will be similar to either assignments or the lecture notes. And if you miss an exam, you get no points for it unless you provide a doctor's note within 1 week after you miss the exam. And in that case, you should also let me know by email before the exam. And about classroom code of conduct, these are the same for all courses in the college, and also cheating and plagiarism policy. So please make sure you read this part here, these two parts very carefully as well. And this is the grading system. I'm sure you're familiar with it. Okay, so let's get started with the first chapter now. So stop share. Okay, so let's start with the very first chapter. So chapter 1, logic and proofs. So we'll start with the first section, which is about propositions. So what is a proposition? Well, proposition is a declarative statement, or declarative, let me say, sentence, declarative sentence, which is either true or false. So any sentence that can be categorized as true or false, and it's declarative, so it's not a question, for example, is called a proposition. So a proposition is denoted by P or Q or R, S, etc. Okay, so let's look at an example. So for example, a statement which can be said or determined as true or false. So for example, each week has 7 days. So this is a proposition. So this is a proposition which is true. Okay, but if we say, for example, each week, so another example, each week has 8 days. So do you think this is still a proposition or no? So this is still a proposition, but this time a false proposition. So this is a proposition which is false. Another example, so we said if I ask a question, then that cannot be considered as a proposition. So for example, will you go to the mall? So this one is not a proposition. So these examples are not mathematical examples, but we can of course consider mathematical examples as well. So for example, let's say if I say, let's say 2 plus 2 equals 5. This is a proposition, which is false, right? So it still is a proposition, but it's false this time. Okay, now another example, let's say 2x equals x plus 1. So do you think this is a proposition or no? So in order to answer this, we have to know whether this can be determined as true or false or no. So in most examples we saw, well, they can be determined as true or false. But for example, when I said, will you go to the mall? So this cannot be said it's a true statement or false statement. So that was not a proposition, but the rest were propositions. What about this one? 2x equals x plus 1. But we know that this is a very simple linear equation, and we know that this equation holds and is true only for one value of x. You know, you can easily solve for x, x is equal to 1, right? So only if x is equal to 1, this is true, and otherwise it's false. So I cannot say whether this is true or false because the value of x has not been specified. So this statement, whether it's true or false, depends on x, but x has not been specified. So this one is not a proposition because there's nothing being said about x, and therefore I cannot say whether this is true or false. So this is not a proposition since the value of x has not been specified. Okay, but if I say, for example, let's say if x is equal to 1, then 2x is equal to x plus 1. Then this is a proposition which is true. Okay. All right, now we need to also know about operations between propositions. So we can connect propositions together with operations. You know, when we learn about numbers, for example, first we learn what numbers are, then we learn operations between two numbers. Now here also we learned about propositions. What is called a proposition. Now again, similarly, if similar to the for the case of numbers, if I have two propositions, I can connect those two propositions with an operator. So that is called a logical operator. So logical operators. So given two propositions, let's say P and Q, one can connect those using a logical operator. Okay, what are the operators now? So the first operator, so here are the list of important logical operators. So the first one is negation. So what is negation? So the negation of a proposition P denoted by negation P is a proposition which is true if P is false and is false if P is true. So P, remember, is a proposition, therefore it's a declarative sentence. So negation P means it's not the case that P holds. So for example, if I say P, so let's look at an example. Let's say P is, it will rain tomorrow in Vancouver. Then negation P will be, it will not rain tomorrow in Vancouver. Right? So if it's rains tomorrow, then P is true, negation P is false. If it doesn't rain tomorrow, then P is false, negation P is true. So negation P, like we said, has the property that if P is true, negation P is false. If P is false, negation P is true. Okay, so another example, let's say P is 2 plus 2 equals 5, which is a false statement, right? Negation P will be 2 plus 2. So like we said, negation means it's not the case that P holds. So if it, in other words here, I should say it's not the case that 2 plus 2 is 5. So the mathematical notation for this sentence is 2 plus 2 is not equal to 5. So P is 2 plus 2 is equal to 5. Negation P will be 2 plus 2 is not equal to 5. And like we said, if P is false, we expect negation P to be true. And it is the case here. 2 plus 2 is not equal to 5. And that's true. Okay, so this is the first operator. Okay, then the second operator is called conjunction. So again, we have two propositions and we want to connect them with an operator to obtain a new proposition. So like I said, similar to numbers, if you have two numbers and you can add them to get a new number, right? So in that case, addition is an operator that performs between two numbers. Here we have two propositions and we want to perform an operator called conjunction between those two. So given two propositions P and Q, the conjunction of P and Q denoted by P and Q is the proposition which is true if both P and Q are true and is false otherwise. And is false otherwise. Okay, so basically this conjunction is like an and. So if I say sentence one, let's say I have two sentences and I want to connect them with an and. So sentence one and sentence two. So this overall sentence will be true if both parts of this sentence one and sentence two, are both true. And if one of them is false, the overall sentence will be false. So normally, in this topic, we can show the truth values of this, compound proposition. So this type of proposition is called compound proposition because it consists of two or more smaller propositions. So the truth values are normally denoted by a table. So that table is called a truth table, right? So truth table so the truth value of a compound proposition can be determined, or I can say represented, can be represented with a table called truth table. Right? So the truth table looks like this. So let's say I have P here, for example, Q, and then P conjunction Q. So in this table, we have to record, all possibilities, truth values for P and Q and P. And for each case of truth values of P and Q, we have to record the truth value of the compound proposition. And in this case is P conjunction Q. Okay, so what are the possibilities for truth values of P and Q? Well, P could be true or false. It's a proposition, so it could be true or false. Q is also a proposition, so it could be true or false. So each of them have two possibilities. So overall, we have four possibilities. So this could be true. So both could be true, or this could be true, this could be false, or this could be false, this could be true, or both could be false. Now, in each of these cases, we have to determine the truth value of the compound proposition, in this case, P conjunction Q. So we said that conjunction is like an and. If I say sentence one and sentence two, when can I say overall sentence is true? Only if both of them are true. So only if both of them are true, then P conjunction is Q is true, and then otherwise the truth value will be false. Okay, so let's look at an example. Let's say if I say P is that so let's say I will watch a movie tomorrow. Q could be, let's say I will eat chicken tomorrow. So P and Q, right? P conjunction Q will be true only if I watch a movie and also eat chicken tomorrow. If I do both of these acts, I watch a movie and eat chicken, then P conjunction Q will be true. Otherwise, for example, if I watch a movie but I don't eat chicken, then P conjunction Q, the overall will be false. So P will be true, Q will be false, and P conjunction Q by definition is false. Okay. For another example, let's say 2 plus 2 equals 4, and 2 times 3 equals 7. So is this true or false? This overall or compound proposition. Well, let's look. This consists of two parts. 2 plus 2 equals 4 is true. So the first part is true. 2 times 3 equals 7 is false. So first part is true. Second part is false. So overall is false, since 2 times 3 equals 7 is false. Okay, so one part is false, so overall is false as well. Now the next operator, 3. So remember, we are studying operators between propositions, which can help us to connect two propositions to find a bigger proposition, which is called compound proposition. So we have looked at negation and also conjunction. Now let's look at disjunction. So again, given two propositions, P and Q, the disjunction of P and Q, denoted by P or Q, normally we say P or Q, is the proposition, or compound proposition, which is false if both P and Q are false, and is true otherwise. So this is the opposite of this conjunction situation. That case, we said it's the compound proposition is true only if both of them is true, otherwise false. This one we say it's false if both of them is false, otherwise it's true. So in other words, conjunction is usually false unless both of them are true. This one is usually true unless both of them is false. Okay, so which is false if both P and Q are false, and is true otherwise. So the truth table, let's first look at truth table. The truth table, again, you have P, Q, P or Q. So this one could be true, or both could be true. True, false, false, true, and then false, false. So if both of them are true, this will be true. If one of them is true, this is still true. And it will be false, like we said, by definition, it will be false only if both of them are false, and otherwise it's true. So let's look at an example. So we said 2 plus 2 equals 4. This time, let's say we say or. So this is like an or. If we say sentence 1 or sentence 2. When can I say that the compound sentence is true? Well, even if one part is true, the overall compound sentence is still true. It will be the overall sentence is false only if both parts are false. So if I say, let's say I remember the example we said, I eat chicken tomorrow and I'll go to movies or watch a movie tomorrow. Let's say if I do one of these acts only, for example, I watch a movie, but I don't eat chicken. So still, if I say I'll watch a movie tomorrow or I'll eat chicken. So even if I do only one of them, the overall and compound sentence is still considered to be true because there is or between them. Or like in a mathematical example, if I say 2 plus 2 equals 4, or let's say 2 times 3 equals 7. So previously we said if there is a conjunction or and between them, the overall will be false because one part is false. But this time, 2 plus 2 equals 4 or 2 times 3 equals 7. This is true since 2 plus 2 equals 4 is true. So for disjunction, again, only one part is enough to be true, and then the overall compound proposition will be true as well. Okay, so then, and there is another operator called exclusive or there is also called XOR operator. Again, given two propositions, P and Q, the proposition P, the proposition P exclude XOR Q. So this is a notation for exclusive or XOR. P exclusive or Q is the new proposition again. So this is the notation. So plus with a circle around it. It's just a notation, for this operator is true. So you can read this. Read P X or Q. So this proposition, this compound proposition is true only if exactly one of P or Q is true and the other one is false. Okay, so this is the truth table for this case. So again, see we have P, Q, and then we have P X or Q. So this could be again true, true, this could be true, false, false, true, false, true, and then we could have both false. Okay, so if both of them are true, P, X, or Q will be false. So let's compare it with this case. When we say P disjunction Q, we just require at least one of them to be true. So whether exactly one of them is true or both of them true, we don't care. In any case, we say the disjunction is true. But in the case of XOR, we really care that and we require that exactly one of them must be true, not at least one of them. Exactly one of them must be true. So if both of them is true, it's not desirable for us, and we would say that the PX or Q will be false in this case. But if exactly one of them is true, like the second case here, or the third case, we say PX or Q is true. And if both of them are false, again, we would say it's false because we require exactly one of them to be true. So if both of them are false, still the compound proposition is considered to be false. Okay, so for example, again, 2 plus 2 equals 4, XOR 2 times 3 equals 7 is true, right? Because exactly one of these two statements, 2 plus 2 equals 4 and 2 times 3 equals 7, exactly one of them is true, which is actually the first one, right? 2 plus 2 equals 4 is true, but the second one is false.